100 years and 200 years, then you start thinking, well, you know, there are issues about longevity and so forth. So there are always issues on any kind of thing where energy is being used and things are evolving and increasing. So if you ask what could happen to the universe in the short run, the answer is good things, just like for you. And what's going to happen in the universe in the long run, the number of paths that you can take that give you a good life 200 years from now or 400 years from now is much smaller than the number where you would die. Meet someone at the end, although when you're young you don't know that so well yet. But the universe has the same kind of thing. It can die in spectacular ways, or it can die in slow, you know, painful. So when you talk about the long-term future, you can do calculations, and the numbers you get are staggering, right? So you can, in the current universe, we know that the universe is expanding, but the expansion is accelerating. And if that doesn't change, whatever's driving that, the dark energy or whatever's driving, doesn't change, then what you will see is the universe will get more and more lonely because galaxies go outside our horizon. Space expands so fast that so it gets very sad. I mean, because pretty soon it's just our little local group of galaxies. Remember that picture, and there's hundreds of billions of galaxies that we can see. Eventually, roughly 10 times the current age of the universe, there will only be our local group of galaxies left, and they will merge into one galaxy, and that will be it. There'll be nothing extragalactic because there'll be only one galaxy. And eventually the stars will burn out, right? And it gets really worse. Right? And it goes on, and it goes on for 10 to the 44th years, and then other bad things happen. Right? Things just fall apart because you think, you know, some of you might have heard the phrase diamonds are forever. They're not. They have a finite lifetime. The carbon atoms, the nuclei will eventually fuse together to form iron, and that will eventually fall into a black hole and evaporate. So if you want to look to the future, there can be very grim futures, but other things can happen, right? So there was an interesting paper out a couple of days ago saying if the mass of the Higgs boson, which is reported, still not absolutely confirmed, but still likely, is what it is, the universe may be unstable, and the universe we know could disappear in 10 billion years into a universe that's very different. It could be very spectacular, right? But there are also things can happen, and so there are things that the dark energy could turn into something that's attractive, and the universe could be balanced, and do the equivalent of terraforming for the universe and make it last a lot longer. But it's very hard not to make a mistake and stay there. So the long-term future is, you know, it's the same for everyone. It's good in the short run, especially when you're young and you have a good career in front of you. It's very good, and you have a lot to look forward to, but then you have other issues that come up later. So the universe that we're in now, we can expect it to be pretty much the way it is on the scale of 10 or 100 million years or more. And then we don't know. We have to do more research to find out what happens. But we have some time, right? I mean, we only have a billion years before the sun gets too hot for us. So we have other problems to solve before then. Okay, so do you want to answer your question?
Well, I asked how you thought about Higgs theory, how you came up with it.
Okay, so this is an interesting question because in most examples, it's good to word by Einstein, I think, because he did come up with some theories. In most cases in science, the theories just don't appear, but in fact, there are lots of pieces around. So there are many different theories now about how science works and what the right models of physics are. And you do various experiments and observations, and you sort of get clues and directions in which to go, and you rule out whole classes of theories. So we had many ideas about how the universe might evolve and so forth. There were oscillating universes, there were universes that lasted forever, and matter and energy would be created all along. So that it was renewing itself. itself, and the expansion was getting rid of the waste by dilution. So in the old days, we used to pour stuff into the ocean. So now we're reaching the limits of the ocean. You get rid of it if things are expanding. The old debris from old stars, things just gets swallowed up in the immenseness of space, and you create new material. So there are many different ideas about how the universe might have come into being and might evolve. And as we've gone out and made observations, we've ruled out whole classes. And so one of the experiments that I was involved in when I was young, that also was related to the one that did it, was to measure the temperature of space. And that tells you how many times you could have had cycles. Right? So you could rule out classes where the universe has gone through several bounces or more, because there would be too much debris. And so you end up having many different ideas out there, and then you make observations to say what kind of class of ideas would be right. And then you start saying, all right, well, it's expanding universe, it's got stars and galaxies that are evolving with time, it's got this temperature that limits you to the number of possible ones. And then you can focus in and develop those more detail. So it wasn't like it was just somebody had the idea right away. It was a thing that developed over time, where people had these different ideas. It started many years ago, 50 years ago, and slowly developed those ideas, and as they got further along, people have done more and more precise calculations, and it's the effort of many people. There are probably 2,000 or 3,000 people doing theories of cosmology and doing studies and analyzing the data and trying to do calculations predicting what the particular models would be. So that's much more typical about how science progresses than Einstein writing a streetcar in Zurich and having the idea of being on a light beam and therefore having special relativity. That's unusual, but when you look more deeply in that, in fact, it's based on very many observations and a lot of work on people who have done electromagnetism. And so he was using all the background effort in math and physics that had been done for electromagnetism to end up with relativity theory. So in fact, the equations of special relativity were already written down by Lorentz some years before that. And so even that idea that seemed to appear, instantly, was based on very